Okay, so when you have a normal line and you want to find the inverse of it, you reflect it over the line y equals x, which is the same as switching the x and y values. For this line, that line would be this. Now you would do the same for sine x. However, when you do that, the inverse doesn't pass the vertical line test. Therefore, we have to find an interval of the graph where the inverse will pass the vertical line test, and that is between the x values of negative pi over 2 and pi over 2, which gives us arcsin. To prove it is also true that the tangents can be reflected over y equals x. To prove this, let's look at this tangent right here. Now, when we find the inverse of that, it is tangent to arcsin, and the x and y values are switched. Now when we find the property, formula, whatever you want to call it, 1 over, we have plus or minus. And the way we're able to get rid of that is, since the derivatives also reflect, we can say that since, let me get rid of all of these, since the derivative of sine of x, which is cosine of x, is positive between the points pi over 2 and negative pi over 2, the derivative of y, or if not y, of arcsine x must be positive between all those points as well. And that is why the derivative of the inverse of sine x is positive, and we can get rid of the negative and plus or minus.